Okay, everyone. Next lesson and last lesson of this week before Christmas break. So we are doing the topic quadratic inequalities. We've already covered the heck out of linear inequalities and two-dimensional inequalities and all sorts of stuff. Linear inequalities would be ones that have x in them. Of course, inequality means greater than, less than, that kind of thing. Linear inequalities, the variable will be x. A quadratic inequality, the variable may be x, but it's also going to have an x squared in it. So that makes the big difference here. Now, they can be solved algebraically or graphically, and we're only going to focus on solving them graphically right now. We are going to use Desmos. Even though yesterday when I went over how to graph things without Desmos, and you can always plot points, we're going to try to make this a little simpler and a little faster, so please do use Desmos. Split the screen like I have, or if you do it on paper, just have your iPad handy, or even your phone or a computer, you can do Desmos. I will be asking you to sketch a graph on your work, on your paper, or on, if you use your iPad, on your document here. This is how you show your work, because without this, you might as well just be copying the answers from the answer key. So you have to include a graph. Note where the x-axis is shaded. As I get to examples, you'll see what I'm talking about here. I don't expect you to know exactly what I mean by this. So yeah, wait till we get to examples. Don't forget dots or circles. So sometimes when you shade a number line, you get like a circle with an arrow on it. Other times you get a dot. Remember that dots come from, oh, I have that backwards. Oh, good grief. Circles come from strict less than or greater than signs. Also, you can have dotted lines. A dot comes from less than or equal to, and or solid lines when you graph. Like, remember we did linear inequalities where we graphed solid lines, and other examples where we did dotted lines and solid lines. Wow, I'm getting this all backwards. Great education you're getting here. Don't worry. Once I get to it, you'll see what I mean. Write your answers in inequality notation. The answer key is going to have the answers written two different ways. You're only going to be required to do it one way. I don't even think we've covered the other way, so don't worry about that. There will be some exercises with no solutions or all real number solutions, so be prepared for that. It's going to happen. All right, so as you can see, there's a lot of space in between the problems that are given. I went ahead and drew XY axes on all of mine. You're going to need that for drawing your graph. Remember, that's how you show your work. Just a tip, what I did, if you're using your iPad anyway, if you're using paper, this isn't much of a tip, but I drew my XY axis. I click the scissor icon up there, circle it, tap it, duplicate, move that down, duplicate again, move that down, and next thing you know, you've got your XY axis everywhere you need it. Now you may not want it that way, so I'm going to erase those. You can do what you want. Do what you want. Okay, so here's what I'm going to do. I'm going to type in x squared minus 14x plus 48 less than y. All these problems are going to have a 0 over here. When you do it on Desmos, change that 0 to a y. So x squared minus 14x plus 48 less than y. And that's the graph I get. And so when I sketch that over here, the critical numbers are at 6, 0 and 8, 0. The vertex, I mean, it's good to know where the vertex is, but it doesn't matter so much. You'll see in a minute. I get something like this. And then let me go ahead and shade it. I'll use the red so it looks just like the screen. You don't have to use these colors if you don't want to, or if you're using pencil and paper, you just shade it in with your pencil. That's fine. Oops, looks like I got a little sloppy there. There we go. Oh, I can't have that. There, we'll just leave it like that. Okay, so the question is, what part of the number line is shaded? Well, that's going to be from this x-intercept to that x-intercept. So that's the x-axis. X is shaded between 6 and 8. Notice I used less than with no equal to because there was no equal there. Or you might notice that this was a dotted line. Dotted line correlates to not having an equal sign, which is why I drew circles around the 6 and the 8. Notice you only use the 6 and the 8 in the answer, not the zeros. Those are y coordinates. Y coordinates don't matter. It's just the x's that we are concerned about. Okay, I've circled and highlighted a bunch of stuff. But in essence, that is the answer. That's what we're looking for. When you go down to check your work, that's what you're going to see right there. This is the other way of writing the answer, and I'm not getting into it. It kind of looks like the point 6, 8, and it's not. It's a whole other thing. It's called interval notation. Don't worry about that. All right, that's how you do this problem. Let's try number 4. So clear this out. Negative x squared plus 6x minus 5 is less than 0. Wow, that's a weird looking graph. Did I type something? Oh, not less than 0, less than y. Duh. Man, I explained to you how to do it, and then I just do it wrong. Less than y. So we get a graph like this. So the intercepts are at 1 and 5. Again, that's a dotted line. There's no equal sign here, so those get circled. My parabola goes kind of like this. Nope, it's got to be a dotted line. And it is shaded out here. So the question is, where is the x-axis shaded? Let me change the color a little bit. It's shaded here and here, right? That's where the yellow has it shaded. So that means we've got x is less than, that was 1. Oh, that's greater than, duh. X is less than 1. And then this other arrow, x is greater than 6. And then when you have two inequalities together like that, you put this symbol, it's called the union. And that's the answer we're looking for. Let me go check and make sure that's right. Where'd I get 6 from? Clearly that's a 5. Oh my gosh. Wow. Dumb. And now I'm tapping the wrong thing. That was a 5, and then I misread it as a 6. Okay, my next one, my goal is to do this without messing it up. Sorry, guys. Just getting a horrible education today. Hopefully through it all you can still learn what it is I'm trying to explain. All right, let's start over. Number 6. So x squared plus 16x plus 64 less than y. Don't put a 0 down, put a y. If I hit the home button, I get my graph like this. Ooh, that's bizarre. Check and make sure I typed it in right. I got to check the answer on number 6. I think this is a special problem. Oh yeah, sure is. So look, my vertex is right there on the x-axis at -8. But it's a dotted line, which means that it actually doesn't touch the 8. It never actually touches the x-axis, and it's shaded up here. So the question is, where is the x-axis shaded? The answer is, it's not shaded anywhere. If it's not shaded anywhere, there is no solution. So the answer to number 6 is going to be a no solution. Oh, that's number 8. Number 6 is no solution. Yeah, that was a tricky one. I had to look at the answer. I had to cheat. Okay, number 8. So we've got negative x squared minus 3x plus 40 greater than or equal to y. Again, make sure that on Desmos you are using a y, not a 0. Hit the home button. Actually, wow, that's quite a crazy parabola. Well, it's not all that important how tall it goes because we're just looking at the x-axis. So if we call that -8, we call this +5, and just, hey, the parabola goes way up high, We'll just pretend that's way up high. And then it's shaded right in the middle there, like this. So the question is, where is the x-axis shaded? It's shaded from the -8 to the 5, everywhere in between, including the -8 and the 5. There is an equal sign here. So our x is between -8 and +5. That's why I can't read my own handwriting. I thought my 5 was a 6 on the different problem. Right there. We got left and right shaded in between. That's what it should look like. Let's check number 8. And there it is. Okay. Maybe you get this already. You're good to go. Maybe you need to watch more examples. There's nothing particularly more difficult about this, except, well, I guess we have one coming up that's going to be all real numbers, so you might want to keep following along for the next few minutes. -x² minus 5x plus 6 less than or equal to y. Again, make that a y. So my x-intercepts are at -6, +1. It's a solid parabola, which means those will be dots, not circles. There is an equal sign there. It's shaded on the outside, so out here. So where is the x-axis shaded? It's shaded that direction and that direction. There is no shading here. So we've got x is less than -6 for this arrow. That was a -6. And this arrow, x is greater than +1. And then you put the little union in between them, excuse me, and that should be the answer. There it is. Did I say greater than or equal to? I did not remember my or equal to. Dum-dum. There's an equal to there. There needs to be an equal to on the answer. Sorry about that. Yes, I called myself a dum-dum. You can call me that too. I give you formal permission to call Mr. Haskell a dum-dum whenever I make mistakes like this. Okay, next one, -x² plus 4x minus 4 less than or equal to y. Now here, the vertex is at 2, 0, and it opens downward, and it is shaded out here. The question is, where is the x-axis shaded? Well, because it's a closed dot, because there is an equal to sign here, every part, including the vertex itself, is shaded. The entire x-axis is shaded. So this just works out to be an all real numbers problem. And that's it. Number 12. Where am I? Right there. All real numbers. Couple more and we're done. If you get it, of course, you can just stop and go on to your assignment. That's up to you. x² minus 4x plus 3 greater than or equal to y. We have +1 and +3 are the x-intercepts. There is an equal to sign here, so it's a solid line, not a dotted line. The shading, we'll go with blue, is out here. Just scribble whatever you need to do. That's fine. That's not fine. It looks awful. When I pick up the stylus and I start scribbling again, it makes it look bad. So I just got to not pick it up. Okay, enough. So we're shaded here, starting at the 3, and we're shaded in this direction, starting at the 1. So we have two arrows. X is less than or equal to 1 is the first arrow. X is greater than or equal to 3 is the other arrow. Again, we do have an equal to sign there. That's why there's equal to here and here. And when you have two parts to your answer, you put that little union symbol between them, and that's it. Less than or equal to 1, greater than or equal to 3. There it is. Finally, number 16. X squared minus 12x plus 36 less than or equal to y. Again, use y, not 0. Now here's our graph. I'm going to go ahead and draw the graph over here. So 6, 0 is the vertex. I know sometimes I just use the x, sometimes I use the point. It doesn't matter that much to the big scheme of things. Solid line upward, shaded inside. And again, your answer is the part of the x-axis that is shaded. What part of the x-axis is shaded? Now you might say none of it is because all the shading is up here, but the parabola itself does touch the x-axis in one specific point. So you could say that that one single point out of all of the infinite points on the line, that one single point is shaded. So the answer is just 6. That's the only point on the whole line that is shaded. Not x is less than 6 or greater than. You could say x equals 6. That'd be fine. I have a feeling that they put the answer in brackets like they do on these worksheets most of the time. Let's see. Yeah, there it is. So just the number 6. So that's a thing that can happen on this worksheet as well. All right. Please do the odds. Give me a shout if you have problems. Otherwise, this might be the last time I talk to you for a while. Have a great winter break.